Rewrite the quadratic in the form y equals a times x minus h squared plus k. So you can find the vertex, the range, and the zeros of the function. The zeros of the function are where the graph crosses the x-axis. Okay, so we're back into completing the square. We're going to add the constant to the other side of the equation. So we have y plus 11 is equal to negative 4x squared plus 16. Then we're going to group our x's. Then we're going to factor out the leading coefficient, which will leave us with an x squared in the inside minus 4x, because a negative 4 times a negative 4 is positive 16. So make sure when you're factoring out that leading coefficient, you factor correctly. The next step would be to try and take out the exponent 2 to actually complete the square. So we bring down our x, we bring down the same sign, and we take half of this coefficient of the non-squared term, and half of 4 is 2. Then we have to square this negative 2, which is positive 4, and multiply it to this negative 4, which is negative 16. So negative 16 needs to get added to the other side of the equation to keep the balance. So we now have y minus 5 is equal to negative 4 times x minus 2, the quantity squared. To put it into this correct form, we want to leave y by itself and put the k on the other side of the equation. So I can add 5 back to this other side of the equation. So we have y is equal to negative 4 times x minus 2, the quantity squared, plus 5. That means that our vertex, again, is found at inside inverse, positive 2, outside same, 5. And our range, since the leading coefficient is negative, will be going down forever, minus infinity, and it ends at this constant number, 5. So if we were to graph this, we would go to positive 2, positive 5, and that would be our vertex. From there, the parabola is going down. How quickly and how steeply it goes down depends on this leading coefficient. Now, another thing they wanted besides the graph was zeros. So if we were to graph this and make our little XY table, see if I can fit that in here somewhere. The numbers I'd put this vertex in the middle of my list, 2, 5, and I do numbers smaller, 1, 0, 3, 4. And then I would put these numbers either back into the original. Putting in 0 is pretty nice, because 0 squared is 0 times negative 4 is 0, plus 16 times 0 is still 0. So my 0 is at negative 11. So I'm way down here. And then if I put in positive 1, that'll give you a negative 4, plus 16 is a positive 12, minus 11 is 1. So at 1, I'm at 1. And then because of the symmetry, I know that at 3 I'm also at 1, and at 4 I'm also at negative 11. So our parabola is going down very steeply, very quickly, and there you go. Now the question is, where does it cross the x-axis? That's the zeros that they're looking for when they ask for the zeros. And the easiest way to find the zeros is to take this equation that you've completed the square with and set it equal to 0. So you have 0 is equal to negative 4 times x minus 2, the quantity squared, plus 5. So if we're solving for x and there's only one x in the problem, we'll get rid of the furthest thing first. We'll subtract 5 from both sides. So negative 5 is equal to negative 4 times x minus 2, the quantity squared. Next, we can get rid of the negative 4 by multiplying both sides of the equation by negative 1/4. So we have positive 5/4 is equal to x minus 2, the quantity squared. The furthest thing from x right now is the exponent 2, so we can take the square root of both sides. But when you take the square root, you should write plus or minus. And we can take the square root of 4. So we have plus or minus the square root of 5 all over 2. And I'm running out of screen space, so I need to go sideways. All over 2 is equal to x minus 2. So you can tell here the last step to do in order to get x alone is to add 2 to both sides. So let me write that answer here for you. X is equal to positive 2 plus or minus the square root of 5 over 2. Now this over 2 is only for the radical, Please don't extend the line with a 2 because that would be incorrect. So this is the point here of 2 minus the square root of 5 over 2. And this other point here is 2 plus the square root of 5 over 2. So when you're looking for the zeros, what that means is you set the equation equal to 0 and solve it just like before.